Okay, so we just did the empirical formula of the CH2 to the molecular formula of CH5. By finding the weight of each of the units, 14, dividing it by the total, which gives us how many units there are. But let's think about that just for a second. Okay, so this thing, this unit, one of these little pop-ups, one of these empirical formulas, has a mass of 14 grams per mole, which we just did here. I'll erase this. Okay, so this is the empirical formula. This is one papa. But what if there were two pop-ups? What would the molecular formula be? Well, it would be two of these. So it would be 2 times CH2. And if we distribute that out, that would be C2H4. This is a molecular formula because it's a multiple 2 of the empirical formula. Empirical formula, 2 of them, molecular formula. You can reduce this down to that. What is its mass? Well, I could do 2 times 12, 4 times 1, or what I just did before, it's a multiple of this. So 2 times this is the same as saying 2 times this. So its mass is 28 grams per mole. Mr. G, what if I had 3 pop-ups? Well, that's what's coming up next. 3 of them together. Ta-da! 3 pop-ups. You can have any multiple. CH2. Multiply that out. Equals C3H6. 3 times that 14 gives us, calculator, I think 42. 14 times 3 equals, oh good, I can do math in my head. 42 grams per mole. What if there's 4 pop-ums, Mr. G? Oh, by the way, that's the formula off the bag. 3 pop-ums of CH2, 3 of the empirical formulas, make a molecular formula of CH6. Can be divided into 3 pop-ups. Empirical formula can be divided, this one, C6H6, by 3 pop-ups. Can you have more multiples? Well, technically, this train can go on and on and on. So let's do 4 and 5, just for giggles. 4 CH2 equals C4H8. And that, if you do the math, 4 times 14 gives us 56 grams per mole. And just to round it out, just for giggles, we're going to go get the 5th block, 5. CH2. So there's 5 of those little pop-ums together, 5 pop-ums coming together, gives us a molecular formula of C5H10, which gives us a molar mass of 70 grams per mole, which, by the way, is the answer to the previous question, right? Because that was the formula. We have the empirical formula of CH2. The molar mass is 70. There it is. Mr. G, could I have just multiplied each of them across? Yeah, you could have. But why? When you can just divide. Why do all these steps? I just want you to see that all of these are multiples of the empirical formula. That's the molecular formula. Multiples, the number of popums together. And you can have one, which would be the empirical formula. Number 2, number 3, number 4, times 5, times 6, times 10, times any number. Long, big formula could be made up of lots of little popums. Big train. So that's the difference between an empirical formula, which is the lowest common denominator, and any of the multiples. So all you do to find out which one it is you divide your question, because it gives you the answer. It weighs 70. So 70 divided by 14, I'll do it right here so you can see. 70 divided by 14, you hit the calculator, it gives us 5. So we know it has 5 popums. There it is. There's the answer. 5 times the empirical formula of CH2. Multiply it out. Get to distribute this time. 5 C's and H10, which is here. And if you wanted to check your answer, which I don't recommend bothering at this point, but if you wanted to check your answer, I'll do it since I'm making the video. What the hey? Let's double check to make sure that does weigh this. On an exam, don't waste your time, but I'm just showing you to prove to you that it works. C, there's 5 of them. 5 times 12. H's, there's 10 of them, times 1. 60, 10, 70. Ooh, 70 grams per mole, which is the full cycle. Got it? So an empirical formula is just the lowest common denominator of the number of trains. Can be any multiple, 2, 3, 4, 5, 6, 7, 8, 9, 10. But this one is 5.